Hello students, myself Alam Sigdar. Welcome back to this channel. Today we are going to start Theorem 1.3. Let's start now. Let P be a prime number if P divides a square and then P divides A, where A is a positive integer. First we have to think here, P is a prime number. Here P is a prime number and A is what given is a positive integer. A positive integer. So think it first, what is prime number? What is prime number? The numbers which have only two factors, 1 and the number itself, is called a prime number. Right, like 7, 3, 5, etc. These numbers are prime numbers. Like this 7 is equal to what? 7 into 1. They have two factors, number 1 and the number itself. That's why 7, 3, 5, these are prime numbers. And A here positive integers. So we have to show here if this P divides a square. P divides a square. This means a square is divisible by P. A square is divisible by P. At that time we have to show P divides A. That means P divides A. This means A is divisible, exactly divisible by P. We have to show this. If A square is divisible by P, then A is divisible by P. We have to prove this. Let P be a prime number and A is a positive integer such that P divides A square. Proof. Now, by fundamental theorem, now by fundamental theorem of arithmetic, every composite number can be expressed or factorized as a product of primes. Every composite number can be expressed or factorized as a product of prime numbers or primes. What is composite number? A composite number is a positive integer that has more than two factors, including 1 and the number itself. Let the prime factorization of A. Let the prime factorization of A. Let the prime factorization of A as follows. A is equal to P1 into P2 into P3 Pn, where P1, P2 comma P3 comma dot 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 Pn are prime factors. Therefore, a square is equal to, a square means a into a. So in place of a, we can write this part, P1 into P2 into P3 dot 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 Pn into another value of a, this one, P1 into P2 into P3 dot 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 Pn, where we can write this P1 into P2 into P3 dot 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 Pn whole square. If we write this, then this one we can write like this also, P1 square into P2 square into P3 square dot 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 Pn square. If we put it here number 1 and this one is number 2. So this one we know, if a b whole to the power n, that means we can write a to the power n into b to the power n also. That's why we can write this P1 into P2 into P3 dot 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 Pn whole square. This means P1 square into P2 square into P3 square dot 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 Pn square. We can write like this way. That is, we can write this a square is equal to what? P1 square into P2 square into P3 square dot 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 Pn square. P divides, since P divides, a square, therefore P is a prime factor of, therefore P is a prime factor, therefore P is a prime factor of a square, by the fundamental theorem of arithmetic, Therefore, P is one of what? P1, P2, P3 dot 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 Pn. Therefore, P is one of P1 comma P2 comma P3 dot 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 Pn. That is, P is a factor of, therefore P is a factor of, therefore P is a factor of A. This one we can write here from equation 1, from this point 1. So P divides A square. P is a prime factor of A square, that is by fundamental theorem of arithmetic. So P is one of P1 comma P2 comma P3 dot 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 Pn. From, we can write this from 2. Therefore P divides A square. Therefore P divides A. So this one is easy. Just leave it one example. So example we can understand this nicely. If we lay 90, if we let it 90, then prime factors will be what? 3 into 2 into 3 into 3 into 5. These are the prime factors. If we let it here a, and these are p1 into p2 into p3 into p4, like this. So for p a, there p1, if we let it p, there 2, then these two 90 is divisible by, exactly divisible by 2, like 90 if we divide by 2, then it will be 45 times, remainder is 0. And if we let it in place of p3, then this 90 is completely divisible by 3, at that time it will be 10 times. Like this way, if we divide 90 by 5, then this one also completely divisible. In 9 5 is 1 times, there have 4, 40, 8 5 is 40. That means 90 is completely divisible by 2 also, 90 is completely divisible by 3 also, and 90 is completely divisible by 5 also. Therefore we can write this, if a is there 90, then p divides a at that time, p divides a. If there have 90 square, that means 90 into 90. So these are the prime factors. These are the prime factors. Then these prime factors also completely divisible by 90 square. 90 square means 90 into 90. If we divide by 2, then it will be also completely divisible, and by 3 also it will be completely divisible, and 5 by 5 also it will be completely divisible. That means at that time we can say p divides a square, p divides a square, then p is also divides by a. This one we can prove nicely. Any other example also we can take here. So therefore p divides a. First time prime factorization, we have to let the prime factorization of a, that one will be there, a is equal to p1 into p2 into dot 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 pn. At that time square 1, a square means a into a, that means a value we have to put here, that is p1 into p2 into p3 dot 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 pn, and one more time we have to multiply there, p1 into p2 into p3 dot 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 pn. So this one means that is a square, a into a means a square, then p1 into p2 into p3 dot 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 pn whole square. So this one we can write like this also, p1 square into p2 square into p3 square dot 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 pn square. So now we have to say like this, since p divides a square, this one given, p is prime number and a is any positive integer. So p divides a square given, then p is a prime factor, p is a prime factor of a square, and p is one of what, p1 comma p2 comma p3 dot 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 pn. At that time p is a factor of a. If p is a factor of a, that means what, p divides a. Like this, given one example, and one more example we can take here. If p divides a square, if we let it here 30, then 30 square means what, first 30 prime factors we have to find out, 2 into 3 into 5, 2 into 3 into 5. At that time if we think this one is a and these are p1 into p2 into p3, then a square, that means what, a square is equal to 30 square. 30 square means 30 into 30. 30 square means 30 into 30. This one also like this, we can write 2 into 3 into 5, and another one having 2 into 3 into 5. So these factors, if 2 is completely divisible, that 30 is completely divisible by 2, that means 15 times, and 3 also 30 completely divisible by 3. At that time what we will get, then a square is equal to 30 square is equal to 30 into 30. So 30 prime factors are 2 into 3 into 5, and another 30 prime factors are 2 into 30 into 3 into 5. So 30 square means 900. 30 square means 900. So 900 is divisible by 2 also, completely divisible by 2 also, and 900 is completely divisible by 3 also, and 900 is completely divisible by 5 also. That means at that time we can say a square, that is p divides a square. P divides a square. At that time we can say p also divides by a. So through this we can prove that p be a prime number, that is if p be a prime number, if p divides a square, then p divides a, where a is a positive integer. Dear students, if you like this video, please follow, share and subscribe it. Wish you all the best.